Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by satsearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organisations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello and welcome to the episode. Today I'm joined by Iselina Perez Donnelly from Allen Space. Allen Space is a small satellite company based in Spain that provides services from design to manufacturing and mission operations. Now today we're going to discuss integrating the space and ground data handling ecosystems for CubeSat missions and similar applications. So firstly, Iselina, hello, welcome. Thank you very much for being here with us today. Is there anything you need to add to that introduction?
Hello, Howell. Thank you for the introduction. It's just fine. Nothing to add from my side. And thank you again for giving us the opportunity to participate on the podcast.
No problem. We're great to have you. So let's get into the topic of discussion. Now, many CubeSat missions still procure individual subsystems like OBCs or tt&c units and so on, and they integrate them together. What do you think are the current challenges that you see in this approach taken by CubeSat developers?
Well, this is a very common approach, and we also follow this in our missions. The main advantage is that you have a great flexibility to choose the subsystems of your mission and to adapt your satellite platform to the mission goals and objectives. Of course, this does not come for free. The compatibility among subsystems from different suppliers is not always guaranteed. From connectors to pinouts, electrica and data buses, software integration. There are many challenges to face when integration from different vendors. In our case, in Allen Space, we face these challenges working very closely with our partners, with the different subsystem providers, taking care of the satellite design with a good system engineering process and ensuring that our software will flawlessly work with all the different subsystems. A good design and an intensive hardware in the loop testing is essential.
Yeah, absolutely. At Allen Space, you take the approach of integrating the OBCs, the OBC software, and tt&c, as well as the ground segment for this aspect of it. Now, we know any space mission is only as good as the data ecosystem that can be created, the data that you produce. What do you think are the big advantages in integrating both the ground and space segment into a holistic data handling ecosystem?
Well, in Allen Space, we see the combination of the onboard software, the OBC and the TTC as the core of our platforms. This gives us great control on the software integration of all the satellite elements and allows us to reduce the development times of new missions. We can use our OBC and TTC solution, which we commercially name Griskel, together with our software, select an EPS, an ADCS based on the mission requirements and just build the satellite. We have designed this solution to be compatible by design with many subsystems and vendors. Moreover, we provide a solution for the ground station and the mission control software that is completely integrated with Griskel. We can build any mission with this complete data handling chain, and it does not matter the size of the satellite or the payload. We have interfaces for it.
Right. So you mentioned that the OBC and TTC combination is with the onboard software is at the core of the platforms. Now, OBC and tt&c specs are normally driven by the overall profile of the mission, particularly the nature of the payload and the requirements it has for data downlinks and command. Are you standardizing OBC and tt&c specs in your approach as part of creating the data handling ecosystem, or is there flexibility to meet specific requirements? And maybe if you could give some examples, it might be easier to illustrate.
Sure. We understand that there are some common functionalities and performances required by any mission. For instance, housekeeping data collection, scheduling of operations, telemetry storage and retrieval, FDIR, and operational modes, TMTC communication with ground. For these functionalities, we have Griskel, our ground station and mission control software solutions. Other missions may require additional bandwidth for data download. And in this case, we can add our TOTEM software-defined radio as an additional module. Earth observation or signal intelligent missions may require massive onboard storage. And we can add additional storage module to TOTEM or Triskel, depending on the requirements and the needs of the mission. Our approach is to have different models to add capabilities, performance, or interfaces, but without a need of complete redesign. We also know that there are some missions that will require different interfaces or form factors. For these cases, we are always open to customize and adapt our products to the specific requirements, and we try to be as flexible as possible.
Right, excellent. So they're really modular approach in developing the right system based on sort of the building blocks that you have. So that's interesting. Now, I think another aspect of this where there might be some questions for the data handling on the data handling aspects is the integration of the ground stations into the data handling ecosystem developed or that is in use in space. Is it possible to integrate the ground segment and while still ensuring interoperability with other global ground network operators, which is really important for missions that want to leverage a really large tt&c footprint?
Mm-hmm. The integration with the ground station networks is a must in nowadays missions. Our approach is, if there is a standard, then implement it. Please do not try to reinvent the wheel. This allows the interoperability of our solutions with other suppliers' ground stations and with ground stations networks. We try to be close to these networks and to establish partnerships with them to integrate our communication products.
Well, that's great. I'm sure that all the technical teams involved in the development of those standards are really happy to hear the approach that you're taking there. Do you foresee the integration of cloud as part of the data handling ecosystem that we're discussing, and as a continued part of the ground segment as well?
Definitely, 100%. Our mission control software was developed with this idea in mind, and it's something that our customers are requesting every day more and more. A few years ago, they were demanding to deploy the MCS in-house, and today they want to have the MCS and software as a service solution, and they do not want to care about this in-house servers, maintenance. So for sure, our future developments in ground data handling and MCS will be towards the cloud. If the deployment is fully on the cloud or in a local server, will for sure be a final decision of our customers. But again, we'll try to be flexible here too.
Okay, great. And yeah, I think it's unsurprising, but still technical challenges to overcome, that space is very much following terrestrial solutions and applications that where you see cloud computing used increasingly everywhere. Greater trust in the systems, greater technical capabilities available to companies and to individuals. So it's really interesting. And I guess in that vein, if you could put your foresight predictions hat on, I wondered where you see the data handling ecosystem for space missions heading in the next 5 years.
Well, this is for sure an interesting question. We see more in orbit and ground autonomy, a change of mind between operating a satellite and operating a constellation. For sure, more onboard processing and performance in line with electronics development, and inclusion of artificial intelligence, both for payload and data processing and for onboard autonomy and mission planning. I think the steps will move in this direction.
Interesting. Yeah, I think there's lots of applications that become possible with the advancement of such computing resources. Iselina, that's a great place, I think, to wrap up. Thank you very much for sharing the insights today from Alan Space. Your work at the company, I think it's been really interesting to find out how a business like yourselves handling the full service of a mission approaches the data handling ecosystem, which is so vital for the end users and clients.
Thank you very much, Howell. Thank you for the interview and for inviting us. It was my pleasure.
No problem. And to all our listeners out there, remember you can find out more about Alan Space on the satsearch platform. On the platform, you can find out details of the company's products and services. You can make requests for quotes, for documentation, introductions to the business, more information on anything to help with your trade studies or procurement processes. We and the company would be more than happy to help you. Thank you for listening to this episode of The Space Industry by satsearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.